Deep inside a dense block of 113-million-year-old stone lies a virtually flawless skeleton of a baby dinosaur. The fossil first came to light during a March 2026 expedition that began in South Korea. To interpret what they had found, South Korean researchers partnered with a joint research team from the University of Texas. They immediately hit a massive physical barrier. The fossil was trapped inside a rock matrix so dense that meticulously chipping it away by hand would take a decade. The mechanical force of a chisel is also inherently risky. A single misjudged tap could permanently shatter the priceless bones. Traditional paleontology had hit a hard physical limit. To analyze this historic specimen, the team needed a way to study the bones without ever physically touching them. The solution came from micro-CT scanning, which essentially acts as a highly sensitive, super-powered X-ray. By passing a powerful beam through the solid rock, the scanner bypasses the impenetrable stone entirely, outputting a digital footprint. The process maps millions of internal data points to reconstruct the dinosaur in three-dimensional space. Because the scanner detects subtle variations in material density, it can pick up traces of organic matter that would be invisible to the naked eye. This data revealed that the creature's exterior lacked the tough scales typically associated with lizards. The physical evidence points to a much softer exterior, covered in a downy layer of primitive feathers, similar to a modern lamb. By utilizing physics to bypass the physical rock, researchers completely overturned long-held assumptions about the dinosaur's outward appearance. The digital scan possesses enough resolution to go deeper, digitally slicing into the microscopic interior of individual fossilized bones. These expanding concentric markers inside the leg bone function like tree rings, proving the dinosaur was only 2 years old. The wide spacing indicates rapid growth. Projections show, as an adult, it would have doubled in size. The scan successfully decoded the life timeline of a fast-growing prehistoric toddler by reading the biology hidden inside its bones. The digital excavation then focused on the deepest internal layer of the creature's chest and torso. Right where the stomach cavity used to be, the X-ray identified a startling anomaly: 40 perfectly smooth, sparkly pebbles. These stones are called gastroliths. They are pebbles the animal swallowed intentionally to help physically grind up tough food inside its digestive tract. Through this digital cross-section, the team extracted vivid dietary behaviors from a creature dead and entombed in stone for 113 million years. The scientific yield from this single rock was immense, especially given the regional context. South Korea had endured a 15-year dry spell with no new dinosaur species discoveries. Breaking that national drought with a highly unique, flawlessly preserved baby skeleton elevated the fossil to the status of a scientific national treasure. Because of its immense cultural weight, the researchers officially named the new species Doolysaurus huhmini. The scientific name is a direct tribute to Dooley the Little Dinosaur, a famously cute, universally loved cartoon character in South Korean pop culture. A beloved fictional baby dinosaur now shares its name with an actual historic infant pulled from the region's stone. Modern paleontology uses cutting-edge physics to resurrect ancient national treasures, bridging the gap between 113-million-year-old history and modern cultural pride.